Okay, thank you. Okay, so hello everyone. My name is Petyo, and I'm very glad to be together with you today and to discuss a topic that I kind of enjoy and like talking about, which is how to make our unit integration tests more effective, let's say. This talk is actually inspired by real events, a real story, because in the projects that I have worked on, I have seen different variants. So I have seen projects that have no tests, because there's no time, the client doesn't want to pay for that, and yeah, this is how things go. Projects which have key tests on specific things, and this one, which was actually the project that inspired this topic, was the dream scenario, like a project where you actually have a very high coverage and a lot of tests. I'm talking here about like hundreds to 1,000 end-to-end tests, thousands of integration tests, and tens of thousands to 100,000 unit tests. So a big volume of tests that was created over years by a team of about 7-8 engineers, software engineers. And what happened was that we worked together, we built that huge bulk of tests, like the dream scenario. You refactor everything, you have tests for it. But we actually stumbled on a problem that due to these anti-patterns that I'll talk about, we actually made development more difficult. And this became kind of a weight that we were carrying behind us. And we had the challenge to have to convince the product owner actually to spend the full team sprint. So this is 2 weeks for 7 to 8 people. So actually kind of fourth person months of effort to refactor and improve this bulk set of tests in order to regain more velocity and to be more productive working on it. So that's the backstory behind this talk. And I have structured it simply. I will first begin with an introduction of what good tests are, because then we will correlate how the anti-patterns affect those aspects of tests. And finally, we will mark, while going over the anti-patterns, we will also mark specific things one can do to address them. So, with that we move forward. So, what is a good test? I have highlighted 4 criteria for the test. The first one is that it needs to provide confidence. Like once you run the tests, you need to be confident that the solution works, that there are no regressions, and even while you are building the software and writing the tests at the very beginning, you get an opportunity to find bugs and to identify issues that you didn't think about and catch them early when it's cheapest to fix them. Then the important part, as you all know, is that it needs to provide quick feedback. If you have a test that takes a long time to execute, you will not run it, so it doesn't matter. It's the same as you don't have it. The next one is to be robust, which means both to not have kind of flaky tests that sometimes pass, sometimes fail, but also the tests, ideally, you want them to survive when you refactor and extend the application throughout its lifetime, which was a big problem for us, as I mentioned earlier. And the final point that I'll highlight is with all software, the code should be maintainable. Like ideally, you want to treat the tests as first-class citizens of the code base, not as something extra on the side, which is not actually getting the same love and attention as the other components. So those are our key aspects for good tests. Of course, one can highlight other aspects. It's a very common and broad area, but those are the ones I selected to highlight. And with this, we can move to the anti-patterns and the fixes. We'll talk about 4 anti-patterns. I want to make clear that this is not an exhaustive list. Like, all of you have experience with unit tests and with integration tests and end-to-end tests, so you have your own observations and ideas. But I wanted to highlight these 4 things, and hopefully you will find in them something useful that you can directly apply in your work and everyday interactions. But before we dive into anti-patterns, a little bit of teasing, like to hype them up, a little bit of context for you. Because there will be a lot of code examples going forward to kind of give you an idea. Hopefully they will be visible and big enough for you to enjoy. But to make sure that we're on the same page, here, this is the main framework for a test. I think everyone is clear with that. This is currently using Groovy code, and this is Spock framework, but that's not important. Like every testing framework has something like that. You define the name of the test, and you have 3 phases for behavioral kind of driven structured approach. First you prepare stuff, then you provide some stimuli, and at the end you do assertions of what you expect to be the end result. So you will see that throughout. I think everyone is clear with that. And the other little bit more specific thing is the testing framework that we were using, since I used examples from that project, very high level and anonymized, is again Groovy and Spock, where this is the testing framework there by default. And I want to highlight how it works. The first line here, you see creating of a mock for a user. On the second line, we are actually implementing the mock. So we are, every time that you call user.name or call that method, you get the result, Johnny Bravo. The third one is an example of an assertion. Basically, it's a Boolean condition that either is also true or false, and it results in an assertion. And the last parts are actually more advanced mocking that you've probably seen in a form, which is interaction mocking. Like you actually track the invocation. So with that expression, you actually say that you want to make sure that not only the mock converter is being called, but you can check what data it's being called with, the user, and you can track the number of invocations. So on the first line, we say that it is called once, and on the second line, we actually are even more obsessively compulsive and say, I don't want any other invocations happening. So those are kind of the key syntax elements that will help you navigate the examples until the end. Yeah, the same things exist in other languages, like in JUnit with Mockito, in .NET with Mock, in Jest with JavaScript. But yeah, I picked that one. So, and the final one, as far as subject matter is concerned, is we have the topic will be user management. So I've took like a simulated microservice, simplified it a lot. So here we have data about users. We have name, address, status, and some other additional fields that you see modeled in the entity in the database. And we have a multi-layered application, like with controller, converter, service, repository, standard components of every application that we see in our work. So all the examples will be grounded here so that you are on the same page and don't have to shift focuses between. And with that, we can start with the first anti-pattern, which is mocking overuse, like going overboard with the mocks themselves, which specifically Spock is particularly prone to because it is very easy and convenient. So it's kind of a trade-off. Like they did a very good job with the mocking framework, and it's easy for you to slip up and overuse it effectively. What I mean by that, I've captured with this example here. What we are doing is basically we are creating a user, but we are actually mocking the behavior of that data object. But this is not a complex service. This is just a data object with several properties inside it, like the name, the address, etc. In our project, people kind of slipped up and started with more complex services to over-mock them a little bit, then data objects, and ultimately we reached a point where some people by habit mocked standard collections, like lists, maps, which are very primitive and stable, and you don't have to do that, basically. And why this is a problem? Because it compromises the points that we discussed first at the beginning. First, from a maintenance perspective, it's very inconvenient. As you can see, it's quite ugly and more bulky. Additionally, it compromises the confidence, because when you do this thing, actually assuming that you have good domain model and kind of meaningful objects, there could be some rules and validations behind that structure that I'm showing here. And when you mock it, you can circumvent that. You can basically do a combination that is effectively not possible in the application itself. And then when your tests fail, you're actually unsure, like you lose the confidence, because this might be a problem with the mocks or with your code that the mocks and the tests should be checking. Yeah, this could be a serious problem from that perspective when you work with the data. So how can this be addressed? Multiple steps. The first one is very straightforward. So you just use and construct the data that you need for the test method itself or for the test class, which makes a lot of sense. But from a practical perspective, usually when we test, we have complex data structures. Like it's not just this user with 5 properties. It is actually business users with a lot of related subscriptions and products there, etc., etc. And if you have to build that tree structure for every method or even for every class, it becomes kind of an overhead. Where the second element comes in, because if you need to do that much of work, you will probably not do the tests as well or kind of skim on the effort there. So the second aspect is to invest in the test data itself, like to have proper structure and easily available test data as it is shown here. So you actually have kind of a static instance with a specific static constant, and additionally a static method that you can call and get the data that you need to perform your test. This one is nice, so now you get it out of the box and you can reuse it directly. But yeah, and also it could tie very nicely if you employ this idea of personas in the project. So those are not just specific things for one test, but these are kind of well-known personas in your application. Like Johnny is a user that logs in every day and is very active, etc., while Susie is an inactive user that has her account locked and stuff like that. And if you define it in the test data, then the developers use it as well, the product owner uses it, and it basically permeates in the whole project, which is very cool. Like we had about 20 different personas for that in itself. So that part is cool. The problem with the current code as it is written is that it is global state. Like all the tests that you run in the application are behind that constant and that structure that is being returned. And it again compromises the robustness of the tests. Because one test, you don't know what happens when you pass the data. The service might modify it, something else might happen, and you might get someone changing the name of Johnny, and this is your global Johnny that you have for all the tests that you will be executing. And then you get failures, flaky tests, and you compromise the testing itself. So the approach that we move towards, which is quite good in that situation, is the so-called object mother pattern. Like it's mothers, like creators. You can see it with other names as well. It's not as fixed as, for example, singleton or observer, which are kind of fixed and constant. I have seen it as test data generator, test data factory, fixture builder as well. Like you can see it named like that. But the idea is always the same. Effectively, it's a factory. It's creating your data. So you have user mother, which is giving birth to your users, you have mother for addresses, etc. But the cool part that I like is when it is combined with the builder pattern. So you see this highlighted .build, because effectively you are not all working on the same global state. You are using a builder pattern. So you start with a template. So whenever I say user mother.johnny, I actually get the template of Johnny with his name, his address, his data. But when I call build, it is actually copied over and I receive a replica of that information. I don't operate on the shared one, so my tests can run in parallel and don't have any overlap and issues on that regard. And additionally, you could modify it specifically. So for example, Johnny is not from Sofia, so we can just plug in the builder to modify that aspect of the object. And yeah, also kind of chain this ecosystem of mothers that you have. So you use the address mother for Sofia, and there is this cumulative effect where if you have a lot of these things, actually starting writing the test and the data don't become a problem. You don't invest too much in the mocking, and yeah, all are living happily ever after. So, the second anti-pattern. It is quite common and present in our lives as developers and quality assurance engineers, which is repetition. But I want to highlight also repetition with a loss of the intention of what is actually happening that happens due to this repetition. So I'll use this example for that purpose. Here what you see is, again, a user is created, the tested method is convert at the middle, and then we check that the conversion happened and actually the data that was used in the given part matches the then part. So the conversion happened fine. It's kind of a not very useful test, but kind of a foundational one that serves our purpose for the demonstration. The problem is that we duplicated the data. We have it in the given clause, Johnny Bravo, and you have Johnny Bravo in the then clause, which makes the maintainability worse because you need to copy and do it in two places, and from there you might get bugs due to copy errors, and yeah, the confidence in the test drops from there. But additionally, also the intention is a little bit lost. Because effectively this is the information, but what happens on the conceptual level is that you pass data to the converter and you verify that the key data points are the same afterwards. So whatever you put in first is the same as the result, which due to actually copying the literals is lost a little bit semantically. And how it can be adapted? Like this. So basically you just reuse the data that you defined once and use it in both places, and now logically you just see that whatever was the input actually matches whatever is the result. So if you just see that part, it makes sense to you and the cognitive load is reduced. And the other part that I highlighted here is that I preferred to name the subject that is being tested as under test, because it allows you to orient yourself easier, because you have multiple mocks, multiple services in the code itself if it's a bigger testing method or kind of a chain of tests. And in that one, you can always easily identify who is the main star, like who is the focus of what you're doing. This can be taken one step forward as well, like because the more obsessive amongst you will say, okay, I'm doing 3 comparisons one after the other. Can this be simplified and reduce the repeatability further? Technically, you can do that with utility classes. So you can introduce a custom utility class that basically takes the result, the input, and you list whatever needs to match for it. So there might not be something standard in the library or in the language that you're using, but you can implement it for yourself. This it helps, but my advice here is to be cautious because you need to do it for key things that will have a lot of applicability and will be used in many places. Don't do it for 1 or 2 cases where you need that functionality because you're writing new code for testing the existing code that you need to then test as well, and it becomes kind of a chain of testing that happens for the sake of testing. But this can help as well. The next aspect is testing the implementation rather than the contract, like the idea behind the component itself. This one is very common with unit testing because effectively it's white box testing. You know what is the implementation, you actually need to mock components in that implementation for it to work. And it is inevitable to know the implementation when you do it. But the point is logically and kind of when doing it to focus more on the effects, the contract, the interface that is being tested, and don't go overboard with the internals. Because again, this makes the test more brittle and it is less robust. Like you will refactor the code, and then you have to effectively refactor the test, so you do the implementation twice in both places, which is not as effective. So I've used this example to demonstrate it. What we are having here is the good patterns up to now. Like we're using a mother, we are using a form, so we just construct a data object. We are calling the create. That is our method that we want to test. But then we went overboard with the assertions. So we not only mock the extra service for checking the name, the repository for the persistence, etc., but we actually enforced the number of invocations. We are checking specifically what data is being passed, and we even enforce 0 extra invocations, which means that someone might add some extra method, something more that doesn't break your test, doesn't affect it negatively, but due to the fact that you wanted to be very exhaustive and cover it fully, like have a full replica of the implementation effectively, the test will need to be refactored every time you add something additional functionality-wise into that original source code, which is less than ideal. And to improve it, what we can do in this situation is, again, focus on the initial mocks, which should work as minimally as possible. Like you need to provide only what is mandatory. Like in this case, we need to say, is name okay true? Because otherwise it will be false and we will not be able to cover our use case, like our flow that we want to check. And you need to have the persist for it to work, but nothing besides that. No extra invocations of the interactions that we don't need to track, and with some extra comments you can give even more clarity. So when whoever is having a look, they see that the mother creates the test data, they see that you require the name to match and the user to be persisted, and from there it is just a comparison that whatever you did with that method matches the expected result from a contract perspective. And the last one is ineffective tests. Here, the example I would use is, here you see this kind of a controller method. So here we are just receiving some kind of input, like a JSON. We are calling a service, we are converting to a JSON the result and returning it. It's quite common code that frameworks kind of employ, and you can see it in different parts. But the point is that if we test it, even if we follow all the good practices that we saw up to this point, the test will look something like this. So it's twice as long, code-wise, just to test whatever is the subject of being tested. It has all the same parts. It prepares, it mocks, it calls and asserts effectively. But the value that it brings is very minimal. Like this is a perfect test to do on Friday afternoon. Like you want to check out such amount of tests, you want the week to end, you do work, it's technically work because you're doing good thing, raising the coverage and stuff like that. But this test is not useful altogether. So my point for this type of test is kind of a little bit controversial, but the point is don't write unit tests on that case. Leverage the higher levels of the pyramid, like the testing pyramid, to cover them. So use the integration test for that part. Because as it is shown here in this funny picture, the plug works perfectly on unit testing level. It has the ports, you can plug it in, you can plug it out, but when you look at it as part of the system, it has problems. Like this doesn't work out very well if you need to charge your phone. So the idea is that by being more critical of what we will test as unit tests and rely on the higher level tests which actually capture multiple components and will cover that part of the logic naturally, you can get good results and more efficiency. So to refresh, this was our setup, our context with the layers, etc., of the application. And this is how the test will look like that. So for this will look. So this is a multi-stage test where we are creating a user with a code that I have commented out, but it's basically just a REST call on an API level. So it's nothing sexy, it's nothing inspiring. Then we actually assert that whatever was created was our expectation. And in the next step, we are modifying something on the data, updating the user with the new period, verifying that they were updated properly. And at the end, in the last phase, we trigger some kind of additional background job, some other processing, and we fetch the information to verify that the end result matched our expectations. So ultimately, because the login time increased, when the job ran, it deactivated the user or something like that happened. But what we saw as a test previously is fully covered by this one, and much more is covered by it. So you can use it and leverage it and get more results. Effectively, what happened when we refactored some of the monolithic application into microservices is having the integration tests that covered the key flows and functionalities with extra unit tests for the more obscure corner cases allowed us with less tests to have the very high coverage, like the same 85% that we needed beforehand, and the code that we needed to maintain and use for the test was much less. But I need to cover my bases. I don't want you to exit this talk with the idea that you shouldn't write unit tests and only go for integration tests, because integration tests themselves are problematic from the quick feedback perspective. Naturally, they are more complex, they involve more moving parts, they're slower than unit tests, and there is definitely a benefit to test something in isolation. So this doesn't mean to use a hammer to everything and use integration tests for all. The point is more to prioritize and use the shadow of integration tests to cover some other things which by default get also kind of duplicated and unnecessarily covered by unit testing. And here is an example for that one. A very good example, this is kind of a state machine logic. So we have a user. The user supports specific state transitions, like you can go from active to deactive and to delete it. But if you want to test it, if you are doing an integration test, you need to prepare all the corner cases of the data, and you need to run multiple tests to do that. While in isolation, specifically considering that it's a specific fragment, like a specific class that you're testing, you can even leverage some kind of data-driven aspect. So the table that is colored at the bottom, it actually exhausts the combinations, and you just have a test that constructs something, runs the method, verifies the result, very simple, but exhausts all the variants which would not be efficient to be covered by the other test. So with that, I want to summarize the points that we discussed and recap it for you. Ultimately, what we want to do is to avoid mock overuse, so the overmocking that we saw when you were doing our unit and integration tests. We want to avoid repeating ourselves, and again, to make sure that we don't lose the intention so that a person can more easily read and understand, which helps maintainability. We want to test the contracts, not the implementation, as much as possible. Unless it's Friday afternoon, don't test for the sake of testing. So focus on the more value added that you can achieve from that. And as an extension to that, leverage more and play with whatever you invest in the testing pyramid. So have end-to-end tests, have integration tests, have unit tests, but try to avoid overlaps and simplify from there your task and your job. So those are the key points that I would like you to leave with and to hopefully be able to apply in your work. Because ultimately what we want to do is to test. And I will leave you with this quote that I really like, which basically explains that legacy code is not code written 10, 20, 30 years ago. It is code that doesn't have tests. So whenever you have to refactor it, it is always an experience, like a journey, which is what we don't want to have in our work. So thank you very much.
Thank you, Petyo. Thank you, Petyo. This was extremely. I think that we still have like a minute for questions.
Yeah.
It was really extremely useful and practical lecture, actually.
Yeah.
So if you have questions, one question here.
Yes.
not starting from things which are unrelated.
It is a challenge. So I can repeat the question. Basically, if we want to test against the contract and not with the implementation, how to change the people's habits and way that they do it, right? This is the question. So what we did was with examples. We basically compiled multiple examples from the first discovery that we did on the tests and the problems. And this set of examples, I shared one, but we had like 10 examples for each one of them, so people can see it and appreciate it. And from that part, kind of, when doing reviews, we were thinking about it, and gradually it was more reduced. It was not disappearing because you cannot avoid it in general, but you can kind of control it.
And definitely, if I can add something, definitely you have to reiterate this message with your team in order to get consistent results.
Mm-hmm.